I welcome everyone for the 7th session of Enterprise Artificial Intelligence. So today we are going to have a very good session where we will continue our product recommendations understanding. In the second half, after the break, in the second half, I'll be introducing to you the Hadoop and Spark, which will consolidate your understanding and your collaboration with Harun. So we have many friends attending today. A couple of people will be joining a little bit late. So we have Sairam, Narayana from India, Leela from, I believe, Minneapolis, Kiran from New Jersey, Hema from Virginia, Harun, Harish from California. We will talk and we'll collaborate with each other. As you always see, we communicate in the class, we collaborate, people ask questions, even other people pitch in to give answers. So it's like more like a typical project. You know, all of you are in projects where the teams are nowadays very much virtual. So you collaborate through WebEx, teleconferences, screen sharing, and try to solve problems. So the same thing we are trying to simulate. Only thing is here we are doing a lot of learning and research. So the learning and research changes each of our brain. So that is what is all about intelligence. That's what Stephen Hawking says. Let's give tributes to him. He contributed a lot of things to science and technology. So he says intelligence is the ability to adapt to the change. So I appreciate all of you for taking the steps to change. Change is nothing but learning, so that in the process we become intelligent. So the same thing is true for the enterprises also. The enterprises face a lot of complexity because of competition, because of complex supply chains, because of growing huge data. So as the huge data growing, every company needs an edge. So that's where they need to get a lot of insight about their transactions or every events that are happening in their company. So that is where they need a lot of intelligence. So the enterprises need to adapt to the new technologies, new processes to be competent. So they need to adapt to the change. So they have to maximize all the available technologies. So that is where artificial intelligence is a cutting edge field which gives a lot of edge to the companies if they implement correctly. These are not new techniques. These are, in fact, they are there from almost half a century, 50 years old. But to implement these technologies companies need huge data. Companies need huge computing power. So which was missing last 50 years. Only last 10 to 15 years, the data has grown, the computing has matured and became cheaper. So that is where now historically we are in a time where these companies are rapidly adopting. So artificial intelligence became a prime time show in the enterprises. So its adoption is extensive in every company, and the results are very promising. It's growing like anything. So naturally, it offers us a very good career, a stable career, high-paying career, and very interesting career, because, as I mentioned, you're solving problems for the companies. So that is where I encourage all of you, encourage myself, encourage everyone. You can solve many, many problems for the enterprises. Not only for the enterprises, these artificial intelligence technologies or techniques are a huge applications in high value problem solving, like biomedical research, solving huge medical problems, solving poverty related problems, governments, non-government organizations, research organizations. All universities get grants from their governments. In the US, it is National Science Foundation gives grants. There are hundreds of $millions are spent on solving brain problems, biomedical problems. But all these problem solving needs these artificial intelligence techniques. So they are adopting. So it's in the beginning only. What we see, what we discuss is only the tip of the iceberg. So the journey, I encourage you to continue the journey. Don't give up. This will absolutely pay off. It's absolutely pay off. So excellent. Quickly, we have Siva also joined. We have Nagesh joined. Welcome. Kishore from Hyderabad joined. And a couple of people. Hari Babu hasn't joined it.
I've joined.
Hari Babu, you are there?
Yes, yes, sir.
Excellent. Okay. Hari. Okay. Excellent. Hari Babu also joined. Welcome. We will connect. I'll talk to each of you as we discuss. So let's move forward for the time's sake. So quickly, as I said, first half we will continue the recommendations. Second half we will entering into the Spark and Hadoop environments, which Harun is already discussing. But I'll show a few parts and quickly it's like a brush up to you. As we discussed, recommendations is there everywhere. Companies recommend products. Websites recommend products. And nowadays, almost every company has some product recommendation or some service recommendation for the customers. It's very useful for the customers, and it is profitable to the companies. Companies have realized it's very much profitable. They're making, Amazon is making billions of dollars on recommendations alone. Even you might ask yourself, You might have purchased some books or some products because some site recommended. I'm pretty sure I did that. So we understood in the last class any rating has a product or service ID. Before that user, there will be a users and product. Each product, whatever the products, might have ratings from these users. Many products may not have ratings from that user. So mathematically, you can imagine a typical user item rating matrix. This is users, these are the items, it's a matrix, and these are the ratings. So it means this user, for this product, this is the rating. So as you understood in the last session, this matrix is a sparse matrix. Sparse matrix means not dense. There are a lot of gaps. So it means not all users give ratings for all the products. Only you will have some known ratings. There will be a lot of unknown ratings. So to solve this problem, so our problem, a product recommendations problem, means identifying these unknown ratings. Haribabu, is that correct? Haribabu, is that correct?
Yeah, absolutely.
So what is the technique we use? We use alternative least squares method algorithm, a mathematical algorithm. It is also called collaborative filtering. Mathematically, it is called alternative least square. But in a more business terminology, people say collaborative filtering. When you say collaborative filtering, so it means you are getting these unknowns from the other users. It means if Hari likes something, if Hari and I have similar interests, so probably I might like what Hari likes. That is the assumption. So it is called collaborative filtering methodology. So it uses mathematical algorithms called alternative least squares. So what does it mean? Alternative least squares and matrix multiplication. It uses both alternative least square and matrix factorization. So here a sparse matrix is approximated to a user matrix, a dense user matrix, an item, a dense item matrix with a rank k. It means users will have columns, k columns, items will have k rows. So when you multiply this and this in the matrix multiplication, this k will be cancelled. So it is a u by k matrix. When a u by k matrix, u by k means this many rows. If you say this one, let's say m by k, say 1, 2, 3, this is rows. Those are called m rows and k columns. Here k is 3 into 3, 4, 7. So it is a m by k matrix. This one always you should take the rows as when you mention the dimension of a matrix, you need to take the rows first. So this is 1, 2, 3, something, say 20. 20 by 20 by 6, 20 by 7. Okay. So 20 rows and 7 columns. This item has a 7 rows. These you need to count, maybe 15. So 7 into 15. So 20 by 7, 7 by 15, those 7 cancel. When you do matrix multiplication, so this becomes a 20 by 15 matrix. So it means an M by K matrix. It is multiplied with K by N matrix. It becomes a M by N matrix. So which is nothing but this matrix. So this is a M by N matrix. This is M by K matrix. This is K by N matrix. So this sparse matrix can be approximated to 2 dense matrix. So how do you know the values of this? Yes, that is what the model will predict. Model, what it does is, it uses mathematically the model, all that is coded in those libraries. So it uses the known ratings. So for those known ratings, it identifies these values and these values. As it identifies, these are called implicit values. These implicit values are approximations. Approximations means there will be some error always, some error between this value and what you get out of multiplication. So there will be some error. So the idea is to minimize the error. So they minimize the errors. When they multiply it, they minimize the errors. So as they minimize it, they do multiple iterations. It means they are minimizing, it means they are changing it. So the way they do is, the ALS works is, you fix these values first, then when you multiply, try to equate to them. So these values are changed to minimize the error. Then once you get these values, you fix these values, then you change this to minimize the error. Then you fix this and you change this. Then you fix this, you change. That's why it is called alternative least squares. Least square, actually it's a least square error. Least square error. The error should be least. That is the one. So all these things, you will not be doing it. Those algorithms are coded in those libraries. So you are working on applied machine learning. So you'll be applying these machine learning techniques, or you'll be applying these algorithms which are available as part of these libraries. So you'll be importing the Spark ALS models, ALS libraries, matrix factorization libraries. Then you'll be using them. So this is the ideas which we discussed in the last class. This is the core. You need to have the understanding. Then the methodology remains the same. The process remains the same. For all machine learning, I encouraged you to understand this is the process. You get the data, you clean and prepare, manipulate the data, you take the training set, you'll use that for training the model, you take the test data also, so you apply that model on the test data, so to verify, to identify what is the how efficient your model is. Then you will try to improve by changing the hyperparameters. Certain hyperparameters will be there, something like Kiran, you asked me last time what is hyperparameter. So hyperparameter is something like the K. Here the rank of the matrix is the K. In the last problem we solved, the anomaly detection, which uses k-means clustering, where there how many clusters, that K is different. That K is how many clusters. So whereas here in the ALS model, the K is the rank. The k-means clusters K is different from the K that you use here in the matrix multiplication in the ALS. So here the K is the rank of the matrix, rank of user and item matrix, which is nothing but dimension of the, when you said a dimension, you use rows and columns. So K is, people say rank. In a true mathematical sense, it is not rank, but you can use it as a rank. So M into K into N. So when you multiply, you get M by N matrix, which is the dimension of this matrix. Okay, this is the same methodology we use, continue. So with that, I will quickly review the code which we have done. The last part we didn't do, where we want to take the predictions and compare to the actuals. And then we will use multiple case and try to identify what was the error. Then we'll take the minimum error. So we'll take the corresponding K. That way we can able to continue. Yeah, any questions? Nagesh, how does this sound? Does this refresh you?
Yeah. Thank you very much, Srini. Excellent. Though I have two questions, if you don't mind. Can I ask that?
No, please.
Yeah, one is, when you said the train model, who will select the model, which model you have to take? And the other question to that is, if once model is selected, during the improvement, do you change the model again, or you just train the model and test data? Just those two questions I have.
That's a very good question. For everyone's sake, Nagesh lives in Charlotte, near Charlotte, Cary. So he has been collaborating with us the last 2.5 years. He's working last 1.5 year. So there's a lot of knowledge on the big data engineering. Now venturing into machine learning, which is not difficult if we collaborate with the right people and learn. And the applications are vast. So his question is this: hey, how we select the model? Shall we select the k-means model? Shall we select the ALS model? How do you know? That is the first question. Second question is, you improve the model, then, hey, do we apply this? What happens? The DevOps, in a big picture, what happens? Okay, that's a question. So Nagesh, very good questions. So the first is the training the model. Nagesh, see, most of the machine learning problems fall into 4 categories of the problems. One is, let me go to, I have a slide. Yeah, please see this. This is from Hortonworks. Nagesh, can you see this?
Yeah. I see that.
You see this? These are the broad categorization of machine learning problems. But if you apply it to the industry, you can solve many problems. But something or other, 60 to 80% of problems that you solve fall into these four problems, 4 categorization of the problems. So what they mean, let's quickly refresh. For others also it will be useful. So if you see, let's start here, clustering model. Clustering model means you have data, your problem is you want to group customers. Or you have data, you want to group them so that you want to apply those groups and find out any new data if they fall into these groups or not. It means finding anomalies. So in that situation, you take the data just to group them. Just to group them. So your model is grouping them. Then you apply that model onto the new data, so that whether new data may fall into one of the group or not. If not, you may call it as anomaly. In the case of customers, you may group the customers based on the buying or high value to identify the high value customers. So whatever it is, it uses a lot of dimensions. So you give a chance to the machine to group it intelligently instead of using our own SQL queries to group them, because machines can see a lot of dimensions and can intelligently group. So there it is just grouping. So those type of problems fall into clustering algorithms. So in clustering algorithms, there could be 2-3 algorithms industry gives. Industry means academies and open source communities work together and to provide us libraries like k-means algorithms, LDA, a couple of mixture models, 2-3 models may be available. So out of them, industry may adopt. The k-means is the most widely used. So if your problem fall into clustering, Nagesh, so you'll start with k-means. Then you will also, in your company, you will also play with some LDA model, some mixture model. So that's how you choose the model. Coming to this, we have a collaborative, since it's a recommendation model. Recommendation model is almost 99% of companies uses ALS algorithm, alternate least square collaborative filtering it is called. So there the problem is clearly known to you. You want to recommend out of so many. So there will be users, there will be products, there are ratings. So you want to recommend top 10 recommendations to the users, and what movies or what songs these users might like. So all these things, because you're collaborating with other users' ratings, so you use this algorithm. So these algorithms are developed by the industry. If you take ALS, Nagesh, it was sorry. Continue. Okay.
I have one question here, if you don't mind. I understood the collaborative filtering. The goal is here to recommend a product or the rating movie or anything. In the clustering, is that a prediction that, I mean, the clustering is what you said is like a grouping, right?
Correct.
So what is the goal here?
Which one, clustering or collaborative?
Clustering, please.
Yeah, so this is what exactly, the goal is so take an example like customers. You want to group 10 customers. You have a 20 million customers. You want to group them into 15 groups for marketing campaigns. Okay?
Okay.
So in the case of anomaly detection, you may have data, historical data of all the users logging into the networks. One day you work in Charlotte, one day you work from Cary. So you may use one laptop, you may use you may work in Starbucks from different IPs you'll be hitting. So all the users every day hitting the network, right, Nagesh? So if they group it, Okay, say 10 groups or 12 groups. They come up with some patterns. Okay, these are the broad groups of our company, historically accessing our network. So if any anomaly, when someone trying to hack, so that point may not fall into any of these 10 groups. So that point they can identify as a hack, as an anomaly. Do you see that point, Nagesh?
Yeah.
Yeah.
Okay.
So that is how you go and see what problem you are solving. They say we want 20 groups of our customers. For our marketing department wants it. They want to get a more insight. So sometimes they may not say what are those groups, or can we make some 4 groups based on the data we have. So you are making the clusters. Then they will use okay, shall we use a mail campaign to them, or what you called some promotions to these people, something, or they might do further exploratory analysis on those groups. Like the different business reasons will be there, which you identify. In fact, instead of going from algorithm to the problem, you always start from problem and see where it falls into it, I guess.
Okay.
Yes. Okay.
Srini?
Yeah.
In this example, where different people are logging in from different locations, so they have their historical data, and then they're constantly monitoring to see if there's new person to detect anomaly. How would they know? How would they figure out if it's a false positive or a false negative?
That is a good question. It is, you see, you have clusters, right? You have clusters. So the transaction, so the clusters, you have the model. Model means number of clusters, right, Kiran? That's a good question. So you'll be applying that model on any new transaction. So the new transaction should fall into one of these groups. If this doesn't fall based on some threshold, they treat it as a hack. So as I mentioned, all the machine learning problems are statistical problems. So I also gave an example of credit card transactions last time. So there exist a false positives. So Kiran might be accessing, and our company machine learning algorithm might think it is a suspicious activity. They might allow based on their threshold, or they may not allow. So it is not absolute. It need not be absolute. So it is like a suspicion. Okay, this looks like a suspicious transaction. So they might stop. So then what do you do, Kiran? You will call your company and, hey, I don't know why I'm unable to connect. So then they will allow your transaction. So then that becomes history. So further machine will learn. So machine learning continues and its efficiency increases. Yeah, Kiran, please.
So I understand the concept of threshold, that they've established some kind of threshold based on their training model or whatever. But in this example, what would be the threshold? Okay, 10 users are working out of this office, and for a year there were between 10 and 15, and all of a sudden now it's 20. So where are these extra 5 coming from? So is it something like that on, like, so
no, it's very simple. See, you have groups. Your transaction doesn't fall into the group. That's the anomaly. Whether it is a true positive or false positive, it doesn't matter. First of all, mathematically, those are anomalies. If you don't have any grouping, any machine learning problem, you don't know anything. So put it as a percentage. Say out of 100, how many you want to say false positives, Kiran? Let's say.
Okay, yeah, let's say 2%.
Let's take 10%. Okay.
Okay.
So, yeah, this is how it is. It means we are more cautious, right? Your company says we are more cautious. So, where do you see the problem, Kiran?
No, I'm trying to identify what would be the parameter here. Like, so I understand theoretically the concept. But here in this example, what would trigger an anomaly? Like, what would trigger something to be an anomaly? What is the parameter? Like,
no, we have discussed, right? If you remember, we use that threshold, the maximum distance for finding outliers.
Yeah, I understand that part. So the threshold would be, it's not like a distance, right? So it's like you have number of parameters, like there's this person and working from this office, they might have like number of points. And then based on those number of points, they'll establish probably some kind of threshold. But I'm trying to see in this example, what would be the actual...
Kiran, it is not, they didn't focus on one dimension.
Yeah, so yeah, that's what I'm saying. So it's not one dimension, it's like number of points. And it would be probably a mean of those number of points. And
not really. That is where, just slow down a little bit. So whatever the dimensions you have, mathematically it is a point. So if you have 2 columns, it is a 2-dimensional point. If you have 3 parameters, it is a 3-dimensional point. If you have 10 parameters, it is still a point in space, 10-dimensional space. So human beings can only see 3-dimensional point. So when mathematically, it can be even 1,000-dimensional point. So now you are dealing everything in a 1,000-dimensional space. So the distance between the centroid and any point of 1,000 dimensions, that distance, it is a distance only. Distance of 1,000-dimensional point and 1,000-dimensional centroid. So the distance take care of all parameters in the picture as a package. So the distance is the threshold. So the distance is not a one-dimensional. It is a distance of the proximity it is. Mathematically, it took care of all the 1,000 dimensions. So it is an optimized, if you call it as an average, also it's all okay. But it is optimized closed distance with which threshold simply this point is above this threshold. Mathematically, it is an outlier. How does it sound?
It sounds good, Srini. I think I was trying to understand the actual data points. What would be, for example, in credit card transaction, it's Kiran. Kiran has a spending limit of 15,000 and she shops at this many stores. So they might take these as different, a point might comprises of this information that it's Kiran and her.
That is what, Kiran, I am encouraging you just to think out of it. There is no rule that it is from New Jersey, it is from this. It is not one rule. Your current transaction is a point which contains many things, all many things, but it is a single point. So if you take all your current transactions from last 5 years, their point, each transaction is a point, right, Kiran?
Mm-hmm.
Wherever it is. But over a period of time, imagine your 2,000 transactions as a cloud, one cluster. Okay, one cluster. Now, your new transaction went out of the cluster, the maximum distance or whatever the threshold they put. They want to have more. If they put more distance, means they're keeping a more tight on your this one. So whatever the threshold, let us assume your team decides. Now any new point falls out of this cloud means it can be any parameters. Just it need not be, even though you are out of New Jersey, still you may fall into this cluster only, because your history, the model that is learned might have already taken into the picture. You might have a credit card transactions from a different cities, right, other than New Jersey already. So your cloud, your cluster, that you can take one cluster, Kiran's one cluster of the transactions, or your Kiran's transactions can be 4 or 5 clusters, so that it has a diversity. So whatever the number of case, it can the algorithm can make into clusters. But any new one doesn't fall into this group of transactions means something anomaly. That is the whole idea. Now, yeah, what do you still think? Probably you are thinking a lot.
That's a very good example, and I understand the concept. What I was trying to understand was, like, in this specific example that you gave to Nagesh, I mean, when you were explaining, answering Nagesh's question that different people logging in from different offices, I was thinking, what would be the dimensions for a point, like IP address?
Exactly. That is what it is, a combination of anything. Combination. Okay.
Okay.
It's not. It's not one. It's not one. If it is one, we would have done simple queries, right? People dialing from this. Why do we need machine learning? It is not. But start with that. You still think, you know, but have that in the understand in your mind. Yeah. Don't think too much. Also, just to think. Okay, at least in a simplified view, these are the clusters. If any point fall out of this cluster, you can call it as anomaly. You can call it as an anomaly. If you talk to 10 people, they will say it's an anomaly. But that point, your question is very good question. Why? Because that point can be a 1,000-dimensional point. It means whenever you say it's a point, it's a package of all criterias. It's not just one. It's not office. It's not a timing. It's not a spending limit. It's not a, or if in the case of logging in, it could be IP and from which country it is coming, what system it is trying to hit. It's a combination of it. Since there are so many people accessing it and so many missions, people can't use the what you call human coded logic. Instead, let the machine decide. Machine can broadly decide. So it is far better than having no mechanism. We are keeping some mechanism, some intelligence to our mechanism. Or okay, allow everyone, because anyway we are not seeing a big deal. Allow everyone, but at least let us monitor. Let us gain nightly batches and see what is happening, and then check. Okay, let us identify false positives. Let's improve our system. So it is like that. It goes. It is like our improving mechanism. Those are good questions, both of you. Nagesh, you have any other question? You're on mute.
No, I'm good. I'm good. Thank you, Srini.
Okay. Quickly, see, it could be classification problem. It could be linear regression problems. So for classification problems, if you see, there are more algorithms, more number of algorithms. So
right.
So you have to see the problem first when you talk to the people. Hey, we want to do a machine learning problem. Hey, we want to do a product recommendations. Then okay, it falls into collaborative filtering. If we want a classification problem, hey, Our mails, we want to say a mail as a spam or no spam. A credit card, when you apply application, approve or deny. If your college is putting a machine learning system for students, approval or deny. It's a classification problem. Yes or no decisions. Yes or no decisions. That falls into classification problems. So like the first, you in a broad sense identify your machine learning falls into any of these four categories. So this is a technique. This is not a problem solving. It is a technique to reduce the dimensions. If you have 1,000 dimensions, you may not need 1,000 dimensions. You can reduce those 1,000 dimensions into 500 dimensions or 600 dimensions without losing the sanity of the thing. So this is not a really an algorithm to solve a problem, but these are the four broadly used categories of the problem. Okay, Nagesh, good questions. Okay, keep moving. Okay, anybody else has a question before I go to the code and show? Kishore.
Yeah, Srini, had a question. Yeah,
Please.
if you have time, I'll just take one. I just wanted to like, yeah, Srini, now what we understand is okay, depending on the problem, okay, we try to come into one of the four techniques, what you have classification, okay, regression, clustering, and collaborative. Okay, once we come there, okay, so that is the first step. And once we come in there, okay, when we try to train the model, right, okay, so just now you are discussing about ALS, okay, what is more important from the real-time standpoint? Is that the accuracy of that particular model you want to, or the performance of the model? So what is that takes to like come to a final conclusion when you try to train the model?
That is a very complex question you asked, Narayana, our friend Kishore. It's a good question. Okay.
Yeah.
See, wait a minute. Let me share the desktop. Okay.
Because what I saw is in ALS also we were discussing when we were discussing M by N matrix, Srini. Okay,
Right.
so there are like multiple permutations and combinations. We try to like change the values and try to like create some kind of an accuracy over there, or are we trying to say that okay, I want to be more efficient, or my performance of the model should be more efficient there?
See, this is the first thing. This is the process you need to follow. Okay. This is the last step. I think we haven't matured enough to fully focus on it because there are a lot of things we need to discuss here, right?
Yeah.
So it is very natural. You have inquisitive to go and hit. Okay, I want the best thing in the world. It's very natural. Everyone want to have best life in the world. Sure, that's correct,
Yeah.
right?
Yes, Srini.
But
we strive for that. Yeah.
Practically, there is no best life, right? It's a optimized life, right?
Yes.
Okay, under your constraints, within your constraints, what is the best car I can buy? What is the best house I can buy? What is the best family I can build? How many number of kids I want to plan? Sure. But
yeah.
For me, the best is 3 kids. My wife said, no, only 2. I can't. It's okay if you want to get another marriage. So, Kishore,
you're lucky she said 2.
What is that?
You're lucky she said 2.
Okay. Yeah, Kishore, okay, you just started 1. Okay. Now, so you focus on improvement based on the situation, right? Kishore,
Yeah.
I can't speak more than that. Better.
We'll take it offline, Srini. No, we will.
You got what it is. Okay.
Yeah.
Okay. Let's move, guys. Yeah, I appreciate your questions. Let's move. Okay. Okay, but one point I want to encourage everyone now here. You see, see here, the process remains the same. You try to understand for every learning problem. Don't miss this point, everyone. Get the data, clean and prepare, manipulate data, You need to identify the training data. You need to test the data. See, this takes so much effort. You don't understand. Lot of problems spend almost 90% of the time here. Of course, they will be improving. Then another question, actually, I didn't answer. Nagesh asked, how you apply these models? Nagesh, you asked the question. I'll talk a lot of details on this later.
Yes.
But quickly see, the training model, these models, Nagesh and everyone, these models can be saved onto a hard disk. These models can be exported. These models can be stored in a data store, a Cassandra or Mongoose. They can be exported. So once they can persist it, it means they are from the DevOps point of view, they can move anywhere in the network. So, and you will be working with a lot of cross teams, like web services teams, where these models will be available as a web service calls for the cell phones, as a mobile app or a web app or a backend as a backend services. So n number of combinations are there, Nagesh, to deploy these models. That is number one. Number two, how often you refresh these models. That is a business decision. So sometimes your models can be every month you will be refreshing the model. Sometimes it is every week, sometimes every day. But remember, these new models to come, you need to train. So sometimes this training might take some 24 hours. Suppose you have billions of rows with multiple dimensions, the training might take 10 hours. So you may not deploy every day. Even you create a new model, you need to test that model. You need to see the efficiency so that you don't break the existing model. So it's a lot of decision. So how many days, etc. It's a business decisions. Please collaborate with your teams. There, you instead of you deciding, discuss with the team and identify and able to take it forward. You can think it as a DevOps point of view. So, but just to highlight, you will have to work with a lot of teams. So don't think you will do everything in your company. So generally, a lot of people, when they are doing work, they think only their work is everything in the company. So nothing to downplay anyone, but just to highlight, I used to think, oh, I'm the only one, and I and my team is the only one do everything in the company. But slowly, the more you know what other people are doing, what other things, you'll really appreciate how great the teams are, how complexity the problems are. We work in Apple, we know. We have Hema and others work in web services teams. I, Harish, and Harun work in customer systems teams. Then we have to work with SAP teams, then iCloud teams, Apple Store teams. A lot of complexities that overall the business will run. So at different places, you will have to work with them to deploy your stuff. So it's a huge collection of teams with which you'll be working and ultimately deploying and solving the problem. But at the same time, try to understand the crux, the central, the heart of the problem is the model and its improvement. But how you deploy it, where you deploy it, whether it's make it available to cell phone, all those things are very routine things. They are there, even without machine learning also they are there. And moreover, question to Hema. Hema, when you develop web services, Hema, will you know every time who will be using your web service?
No, we will publish the interface SIA, and whoever is going to consume, they will follow that standard. That's it.
Exactly.
We don't.
So you will not be, so answer to the question, you will not be knowing, right, who will be using it. Maybe one customer you will be using, but tomorrow 10 customers might be using it, right?
Right.
Correct. So that's the beauty of this service-oriented architecture, etc. Nagesh, does that answer your question at least fairly?
Yeah. I have a question, if you don't mind. I don't know whether I should ask you now.
No, please go ahead.
Yeah. When you say the model, my understanding till now, as per so many sessions, it's only an algorithm or mathematics formula, something like that. So when you say your saving model, how is that different from what you're going to deploying it?
Okay, that's a very good question. But I think it helps many people to understand this. So
yeah, that's what I want to see. If you can show me in the code what exactly you're saving, I just want to understand.
Yeah,
I was not clear on that.
No, definitely. But first to understand, see,
okay, sure.
What is a model? What is a model? In our case, the model is, you see, if you talk software point of view, Leela, Nagesh, Hema, everyone, software point of view, algorithm is not a model. Algorithm help you to get the model. So using ALS techniques, you get a ALS model. But model is an instance. Please observe. Model is an object, Nagesh. A model is a software object, actually. Okay. When you say ALS modeling, modeling is a class, a software class with algorithm. Using that algorithm, using that class, you suppose I trained it. When I train it, I get a ALS model. So my model based on my data with my hyperparameter, what I got is a one instance of ALS model.
Okay. Oh, okay.
It's a software object. So that software object will have, it's like any object. It has attributes. It has a functionality, right? So it means when you say I save a model, I am saving a software object. So that object has certain information available, which are attributes, certain functionality available. So if I take that object, if I take I hope everyone can see this. I'll make it, anyway, I want to go to this code, not just because Nagesh asked. It's a question to everyone. Let me take it. Give me 1 second. Let me show you. Say you have a model. Say you have a model. Nagesh?
Yep.
Okay. So this model is based on these parameters, based on the training data. So it is a model object. Which is your model is a software object, matrix factorization model, but an instance of it, right? So it means this model is an instance, a software instance object. So this model, if you save it, if you persist it, or if it is available in the memory, this model will help you to get a recommendation for a user, one user. Suppose one user you are passing. You want to have a a what you call top 10. This parameter I will tell you later. N is actually N. Actually, it's N. You want to have a top 10 ratings for this user. Top 10 recommendations you want, right? So it means if you pass this user ID, say from an app, mobile app, you are getting who is the user, and for that user you decide some top 10 products. If you pass that user ID to this the method of the model, recommended products is a method for that object.
Correct. Yeah.
Right?
Yeah.
Nagesh? For that model instance, you get this. Now you got it?
Yeah. Yeah. So when you say that that ALS is a class, the model is an object, it was an empty before training. After training, it has got some data in it. So that's what you're saving for the using that, right?
That's correct.
Is that the way?
That is correct. That is correct.
Okay. Excellent.
It's a good question. See here, now suppose I can pass the parameter as the K, which is the rank. So instead of set rank, some hard coded, I can pass multiple Ks and see its efficiency. Anyway, let me go to that. But now you asked a good question. So everyone, do you understand what is that model? Because it's a general question for irrespective of any machine learning problem you are trying to solve. So, but don't worry, where you save, etc., where it goes, etc., don't worry. But at least you need to understand what is that model. Now, Nagesh, you understood, right? This model is a instance of the object. So it means it has encoded the intelligence. It has encoded, the model has those ability to calculate the recommendations. So it means wherever you take it, it has that, right? You want to add, you want to give some explanation to our team based on your understanding?
Yeah, I mean, I understood. So you're trying to, the model before you starting, it was an empty. And once you train the data, when you run that, it is capturing some parameters or some data so that when you save it, you can test it and as well as you can run with the new transactions.
Right.
So, yeah, okay. This is very good. Thank you.
I see. If possible, I'll try to show you where to save, etc. But don't worry much about it because there are a lot.
I'm not bothered about the saving part, but I was only concerned. I was not clear when I speak. When you say model, I was thinking, but what is saving? What exactly is the difference? I was thinking. Okay. Thank you.
Absolutely, very great question, especially for all the team to understand, because I use it very frequently. My understanding on it is maybe very easy, but now you asked, asking is very, very important. So that helps me to articulate more. Now we are thinking it in the perspective of an object. Everyone knows a class and object. So that is a really, really good question, Nagesh.
Thank you. Yeah.
Okay, before I quickly walk through what we did and the last part, evaluating the model, improving the K, before to do that, any other questions? I want to give chance to everyone. Siva, Kiran, Hema, Harun, Harish, you're so silent. If you're silent, I'll be a little scared. You know, Hari, you're also silent today. But does it help in you?
We are listening to the input.
Very good. That's a good question, right, Nagesh? What he asked.
Yes.
Helping you?
Yeah.
Harish, you have any question? Does it make sense what we are talking?
Absolutely, Shini. Yeah, I'm able to relate.
Yeah, I agree. It appears a little bit complex, but slowly I believe it's coming into your phone. You get the data, you clean and prepare. A lot of work is here. You see here, now lot of work is here. You'll have to write functions. You'll have to read the data. There's a lot of work and lot of jobs are here. Okay, very good. But having a clarity, yeah, Hima, please.
So when you say how often the model is refreshed, so when model is refreshed, meaning the value of the parameters can change, like how often, like the k value can change that, or as
more than parameter, data will be changing.
Actually, data will be changing.
Mainly,
okay.
Yeah, see, new data, you said, right? We identified 10% false data. In a month time, you may have thousands of false positives, right?
So that data is, are we talking about the training data or?
Yeah, that once the new data, today's new data is tomorrow's history, right?
Right.
So after 1 month, don't you think we have a new history to learn?
Yes.
Yeah, that is the point.
So, but that is still a training data, or is it a testing data?
No, see, that is a historical data. Out of this historical data, 80% you will use it for training, 20% you will use it for testing. So you have a history. You have, and out of that, you take 80%, use it for training.
Mm-hmm.
Take 20%, use it for testing. Right?
Yes.
Then you have a new model, right?
Mm-hmm.
But the new model came from where? On using the training data, right?
Mm-hmm.
So the training data has now the new last month, 1 month data, right? At least 80% of 1 month data, right?
That's correct. Yes, sure.
So that is the whole idea. Everything driving is mostly your data. And here and there, okay, hyperparameters, you will tune it, definitely. But you and your team will be deciding it. You cannot just decide, right? You'll be working with the team, saying this is what I think this is what it is. Like that, first time generally you'll fix the case, etc. Going forward, it might slightly change. But the very idea why model changes is because of the new data that is coming. You want to learn from the data. The learning is more from the data. So these new models, you'll be constantly every week, whether you deploy or not, you may be testing those models. You may be training and comparing and testing it, getting some insights, discussing it with the teams, and taking inputs from the current implementation. The current implementation you'll be discussing with the business users and trying to understand how your machine learning system helping them. But the good thing is it need not be perfect. That is what is the machine learning system. It is a learning system, means they are going to improve. Even the companies knows, hey, our system 50% good now. So we need more data to improve the system. Your algorithm, your hyperparameter cannot make it more efficient. Maybe you can fine tune maybe 50% to 60%, but after that you can't do anything. Your algorithm is a math you fixed. The hyperparameters is from maybe you have 5 to 10 values. Maybe 1 or 2 types will be there, but the values can be a little bit different, which you've been trying to apply. So your hyperparameters are not dimensions. The 1,000 dimensions I talked is the number of columns of the data. You take a weather report, they may have 1,000 parameters. Those are 1,000 dimensions. But the hyperparameters we are talking about is for algorithm. In the case of ALS, only 2 hyperparameters, but the mainly is the K. Next is a number of iterations. Number of iterations may not improve a lot. once you choose something. Only two. In the case of, in the case of k-means, clusters, number of clusters, your hyperparameters are the number of clusters and what is the threshold you want to use to improve. That's all, these two only. But these points can be even 500 or 100 or 1000 dimensional point. So kindly note, the dimensions of a point is different from hyperparameters. So they're important, but don't break your head too much. Most of the work is getting the data, cleaning the data, training based on these whatever the dimensions, testing it. Then comes the last step. So don't jump. You can understand this, but don't jump too much on this. So understanding the model that Nagesh asked is very important question. Have a clarity. So that would help. Leela, you have any question? Does this gives you very good understanding, if not very good?
Yes, Srini.
Okay, that's good. Before I run the code, I want to encourage now everyone. Please observe only the model changes. Now you have understanding of two problems. One is anomaly, another is recommendations, which I need to dig more. With these two problems, for all these two problems, getting data, cleaning and training and testing and hyperparameters, it's all same. So now you can solve two problems in industry. Try to focus on them. Try to gain more insight about understanding, getting data, how to get data. How can I take help from Harun and the team and read it as RDDs? How can I clean it? How can I apply transformations and writing some functions? So how can I learn more Scala? Focus on it, please. Then how I train, when I train it, how I am importing the libraries, how I am testing it. So you understood the problem. Now you can able to solve two problems and learning all this Scala and handling this. With that, in fact, you are ready for job to solve two problems in the world. You can even check with people. Hey, I can solve recommendation problem, machine learning problem. So that is the beauty. You need to see yourself like that. Though you will be learning a lot of things in the coming classes, they're vertical problems. You may be solving classification problems. You may be solving regression problems. But for a lot of companies, they may be first solving the recommendation problem and anomaly detection problem. So mentally be ready. That's what my idea. Okay. Any other questions? Okay.
So can I comment this, Srini?
Please.
Yeah, it looks like if you are given 15 days to work on this problem, so it looks like 80% of the issue is only data cleaning, data preparation, and all that. But the machine side, whatever you're saying, selecting the model, testing the data, training data, it is very fast, it looks like.
Absolutely.
Okay.
I agree. Once features are given, it's just cluster, right? Only thing is, even if it takes 10 hours, it's still fast, it seems, because generally, because of the cluster. The idea is that, right? Yeah.
I mean, as far as the machine learning developer point of view, also, the more time is spent on the data cleansing, getting the data, and all that.
Absolutely.
But okay.
Absolutely.
Thank you.
That's correct.
Yeah.
Okay. Guys, quickly, let's walk through last time. Hema, comment on this. What we are doing here. We are importing here. What we are doing here. We are getting the data, rating data. So I have a user data which has, I printed here, this is user ID, this is the product ID, this is the rating, this is the Unix timestamp. I'll be using these three only. So from this raw data, I'll be taking 3 elements. After I split, I'm splitting. This is a tab dimensional. I'm splitting it. This is still a string. Please observe. I encourage everyone to focus on these data types. The Scala gives a lot of insight about how the transformations are happening. Moving forward, you will be also picking up some PySpark. I will be helping you, which is not difficult, but you will see, you'll really appreciate Scala when you do Python and Scala, because Scala gives a lot of insights about the data types and transformation. Python doesn't give. It is easy to code in Python also, but it doesn't give you a lot of insight at each step. But it's okay, let me not disturb you. So what I'm doing is I'm taking this data, user data, I'm splitting it and taking the first 3. That is what I'm splitting it based on tab and taking 3 and printing it here. So I am taking these values, just showing to you. It's the RDD of string became Hema, RDD of array of string, because I split. So when I split, yeah, I got now user ID, product ID, rating for this whole data. Now, for this data, this is still array of string. So this algorithm gives a rating object. See, rating object. Let me go here. So I am creating a rating object. How I create a rating object? Last class, Harun might have explained you to create a case class. And he split a file and passed that information into case class so that it became a data frame. Hema, is that correct? You remember Harun, he took a file and he split it and took that values of the array and passed it to a case class, like a table. Yeah, rating object is also, in fact, a typical either case class or general class. It's an object. It's that rating. It takes the inputs. Yeah. Hema?
Yeah, it's a predefined class and a recommendation
Correct.
library.
Correct. So I'm passing that, Leela. See here, I'm taking that whatever that raw ratings, which is an array, which is an RDD of an array, I can take each line and pass to the rating object. How I pass? Since it is an array, this is the first element, this is the second element of this, this is the third element. I'm passing it to rating, then automatically I get an RDD of a rating object, a recommendation rating object. Please let me run this. I want to show here another flavor of the syntax. See here, Hari, it will be interesting to you and for others. Harish, please observe.
Okay.
See here. Here, the same raw ratings, I took a mapping each item. This is an array. In this array, I get the first element using the index 0, index 1, and index 2. Harish, this is a question to you. The same thing can be beautifully written. Use a case statement. So please observe, when you are learning Scala, case you will be using as a case class and case for pattern matching. Mainly these two ways you will be using it. So case, not only you can use a case class to construct object, case also used to deconstruct the object. I repeat this word. Case to construct an object, case to deconstruct an object. Case can beautifully deconstruct an object. Deconstruct an object, it can take the things out. It can tear it out. How you please see? See here. If I just say case, Hema, Harish, Hari, instead of line, you know this is the type. If you say this is the array of string. So if you say, if you mention that object as an array, and inside you just say this is user, this is item, this is rate, which you know, hey, this is user, this is item, and this is rate. Then interestingly, these variables you can use directly outside. Look here, case, array, user, item, rate. Once you say case of this, it means case of this. Now you can take them out. You can tear them out. Hey, I want this, I want this, I want this. So I want this, I want this, I want this, you can say. So you can pass these values into rating object. See here, rating object, the first element is I want a user. I want this one. Second element, I want item. Third element, I want as a rate. Instead of using these indexes, indexes is a low level array of 0, array of index 1, index 2. But here, see, beautifully, you are using like a metadata. User, I need to convert it to an integer. Item, because this is a string, array of string. So you can pass this one, rate. So you can take it out. Once you say case, you can take it out. That is the beauty, which I will be using it here and there. You see here, you just got the same. You got an RDD of rating object. Look here. Here also, I will run it. Yes. I got a rating object, Nagesh. I got a raw rating RDD using that raw rating RDD, which is of an array of strings, RDD of array of string. These, each elements of this, I need to pass it to a rating object, because rating object is the one which is an input to my algorithm. In the K means the dense vector is the input, whereas in the recommendation model, rating object is the input. That's why I'm constructing my rating object. So my rating object, I need inputs for the rating class, which creates a rating object. So in the rating, I need to pass these inputs, but the inputs came from that file. That file has a now array of strings, which because we split it. Leela, is that correct? So when we split it, I got this raw ratings RDD. One way I can construct the rating object is, which needs inputs, I can just take, I know this is an array. From that array, using indexes I can take. That is one way. More beautiful way in Scala is the case statement. When Harun has taught you in the last class, which he will be, even tomorrow he will be refreshing and making you more comfortable. You can use case classes to construct the objects. Interestingly, case class is not a case class. I won't say case class here. Case statement can also deconstruct. It can help you to tear things out. So if I say case of an array, which is your input of that file for that raw ratings RDD, you say, once you say case of it, and you can mention any names, let's put user item rate. Then you can use these users items very frequently outside. You can use them as a metadata itself. I'll be using more of this in these coming examples. That makes you more comfortable. Right now, just have this observation. It is the same. Now I'm running this, which constructs an RDD of rating objects. Now my ratings RDD is a transformation RDD, which creates an RDD of a rating object. If I just take 6, I have beautiful rating object, which is now my ratings RDD is going to be my input for my ALS model. Any questions? Harish, any question here? I know it takes some more time for you to get this, but keep it as a placeholder, just as an observation. How does this sound? Hari, Hema, Kiran, are you good?
Yeah, okay, yeah, we're good. Yeah.
Okay, okay. Let's keep it for observation. This is the rating subject.
Srini,
Yeah. Please, please.
Just one question. This is a case here, is not a case class. It's different from that. But you're not explicitly defining the case class object here. Without doing that, we can do this. That's what you're saying, right?
Correct. That is not a case statement, actually. It is not a case class. If you remember case class, you'll be declaring case class, right?
Right. Yeah, this is excellent. Because this is self-explanatory, you know. I mean, just looking at the line 1, line 2 in the big projects, you don't understand it, but this makes us life easy.
Exactly. Another thing is, see, suppose you forget to do this. See, that will give you beautiful input to you. See here, I didn't put case. See, tuples cannot be directly constructed.
Oh, yeah. I see. So we cannot
you take this and try to deconstruct. You cannot deconstruct. See here, consider pattern matching, anonymous function. See here, see case.
Right.
Use case. This one, it knows you made a mistake. Yeah, you know.
So this has to be a block code, not just.
It's a block code. It's a map, not bracket. Map block code. Yeah.
Right. Okay. Thank you.
Okay. I'll give you more examples so that you really appreciate this. Okay. Just to keep it as a placeholder. Now you have a rating object. Okay. This is simple. How many total number of ratings we have? We identified 100K. It's a simple print line, a string concatenation. I'm just doing a count, which is an action. Everyone knows it is an action. It is an action on the ratings RDD. Your ratings RDD is, Leela, your ratings RDD is an RDD of a rating object. Okay. I highlight many times these points because these are needed to get into your brain. Okay, very good. Now move forward. How many distinct movies? You just get all the movies, then find its distinct. Simply from the ratings RDD, I'm taking it line dot product, because it's a rating object. The rating, your line is a rating object. Rating object, the object dot product means it's an attribute. You're getting that attribute, product. So this is how the structure of the rating class. Hema shared last time. Hema, is that correct? This is the rating object. Rating object has attributes user, product, and rating. So if you take the products, you get the product. If you take the user, you get the users. Okay. So I get these products. I get the products. What are the distinct of them? What are the count of them? So I have this many products, 1,682 products. Distinct user, simple. Line and line user, distinct. This many users did a rating. So 943 users. This is the product. Hari, now you know, if you remember our user item, this many users are there, this many items are there. Distinct, I'm talking about distinct users. Distinct users. 943 and 1682. So this is also distinct only. You see the matrix? These are distinct users. These are distinct items. So this user, since it is in two-dimensional, you can capture this. See this user, 1, 2, 3, this many products. This user is rating this many products. This user is making this many products. But if you see this matrix, Hari, do you agree with me? These are distinct users. These are the distinct items. Do you agree with me? Here the users are not repeating. Okay, you're on mute. Okay. Distinct users. This is product ratings, total number of ratings. This is simply number of count. How many ratings are there? You see here, user product rating. The same user may have multiple ratings. See here, this user product rating, user product rating. So this user has a 2 ratings. So this is what exactly? This is simply nothing but how many rating objects are there. So rating RDD count will give you this. I run this. Kiran, any confusion here till now? We are not doing anything. Simply I took the rating. I prepared my input. I just counted. Okay. Distinct movies, which we already done that. Items. Distinct users, we created total product. Just I'm keeping everyone on mute just to make sure there's no background. Okay, guys, let's focus before we take the break. So here I'm splitting into my train data and test data. So for that, I take my ratings RDD, use random split into 80% and 20%. Okay, it takes an array as input. So I get splits. Splits is an array. So splits, the first one, which is the training RDD, is 80% one. Splits, second one is a test RDD. So I'll run this. We have seen this before. Okay. So I have a training RDD, test RDD. I cached it. I'll be using it for my input, as my input. So I'll be running my ALS model on this training RDD. Test RDD, I will use it for testing. So this is the, now I'm going for model. Till now, I had done this only. See, this is the beauty. I got the data. I just, we split it. I prepared and manipulated data. I just, to get more insight, I did some counts, etc. And I split my data into training and testing. Then I'm going to train the model. Nagesh, am I going systematically to process? Very good.
Yeah.
Excellent.
Good.
So ALS model came from this library. A lot of people from Stanford, from Apache Corporation, UC Berkeley, all smart guys, ultra smart guys, coded all these mathematics into those libraries and given to us to apply this and solve the industry problems. Okay, so this is a ALS object. It's a new ALS object. Then for the ALS object, I am setting certain rank. Initially, let me put some 20 or 30, some rank. You can choose anything, then we can fine tune it. Set iterations. You can use 10 or 15. This is the number of iterations. Because in ALS, you remember, you fix one, you approximate the other. Then you fix the other, you approximate the other. This is the number of times, number of iterations you want to do. That is also, you can approximate to 10 to 15. Then you can improve that. Then let me go. So based on that, my ALS object is ready. That ALS object I'll run on this data, on my training rating RDD. This is a rating object. Nagesh, this is what we need to focus. The input is rating object. Please observe. Object, software object, rating object. In the k-means, it is a dense vector. Dense vector is the input. So we are running on this data. So that is where you get the instance of the model. The model you got is an instance of that model for this hyperparameter, for this data. Make sense, Kiran? Sounds good?
Srini.
Yeah. Please feel free to ask. You're on mute. Can't hear you if you are speaking. Okay. I will. So I got a model. Leela?
Yes.
This is the model. You tell me what is the data type of this model. This model is of what type? It is a recommendation, and under this package, it is a matrix factorization model. Matrix factorization model. So this model has intelligence. This model is based on this training data and hyperparameters. Just to show you, hey, this model can recommend products. I'm taking one user. 196 is one of the user. Just like this. Here. These are the ratings. This is users. For one of the user, I want to get a top 10 recommendations. Top 10 recommendations, all the top ratings. So I'm going here. This model has intelligence. You are getting more insight on these models. See, user ID, I'm taking 196. Top 10 recommendation, N I am taking 10. Top N recommendations is a variable. I'm applying this model Harish Bokre. This is model dot recommend products is a method in that model. In that API documentations, there are a lot of methods for this model. You can review Hema and we will help you to understand. But focus it, don't digress now, right now. So user ID, I'm passing is a variable, and the N is number of recommendations. Then I'm going to print these top N recs here. Okay, let me run this. See here, top N recommendations. The output is top N recommendations. Top N recommendations is an array of, again, ratings only, right? Top N recommendation is an array of ratings. So 10 ratings. These see 10 ratings for that user. Same user. See, please observe. Same user, but different products. 679, the 6.7. This is the top 10 recommendations. Highest will be here. 6.7 rating, 6.2 rating, 6. Like this. If I take a top 5, I just want top 5. Nagesh, does it make sense?
Yeah. I have one question here.
Yeah, please.
If you don't mind.
No, please.
When you do this recommendation products, when you train it, is there any time this object becomes too large? Because you have so much, it has to think for each user different ratings it has to do. Does it work that way?
That is the beauty. It is not a simple simple functions we know. Actually, they use a lot of heavy lifting. Here they use the
Okay.
matrix, you know, linear algebra packages. Okay.
Oh, okay.
Does the
Okay.
huge collections, vectors, vector products. All those are not simple, just multiplications, matrix multiplications, and huge vectors on the clusters. So they used all these collections, arrays. All that's where actually Scala really shines. And in Python they use NumPy. NumPy means array, special functions on the array. Of course, Java is always great because under the Scala, under the hood, it's nothing but Java. Java supports vectors, any number of dimensions. Only Scala gives what you call a high level usage above Java. The advantage is these guys, Scala has a higher level functions where you quickly can do it. That's the only thing. But under the hood, it's a very robust, very robust. Nothing changes. Crystal clear, and it uses multi-threading and parallel programming. So beautifully, it gets your object. Okay.
I think what I've heard is like Scala is defined as scalable language.
Yeah, Scala is originally, they say it's a scalable language because the idea is to do better multi-threading.
Yeah. So
but again, it's under the hood is Java only. Yeah.
The base is Java. Yeah, you're absolutely right. So I have a small question from my, from a practical point of view. If we have a subset, then for example, when we buy a product on Amazon or whatever the site, so how do we, how are they recommending the related products? Like for example, if you buy a mobile phone, they will recommend this is the cover, or this is the charger, and the related products. So how do we account for that in our in our program?
Yeah, that is a good question, but you need to reserve it for some time. Because that discussion takes to a little bit complex because additional linkage has to be given. But again, if you see in a high level, it is a what you call. It is nothing but a product recommendation only. Instead of giving a random products, they have an option of giving a related products. So, so you say it could be an additional parameter to call. It's an additional parameter to call. So we'll discuss, but definitely that's a very good question. Okay, just like say for this user, what are this one? For this user, assume using that product, they get the recommendation, something like that. Additional parameters can be introduced.
Yeah, because if I take a practical example, I already want to go for an iPhone. Say for example, it's my choice, so I decided for that. Then mostly they will recommend all the iPhone accessories.
Correct.
That's what the real scenario would be. So
exactly. It's very simple,
I wanted to know.
I think I learned here itself. It's very simple. See, for this user, these are all products, right? Suppose imagine, for this user, since he purchased iPhone, now look into a products. Suppose they have a table, all the related products for each project, each product, some related product table. So related product data set.
Correct.
Look up, and it's an additional filter only, right? Sorry.
Correct. Absolutely. Yeah.
Exactly.
So how do we?
No, no, don't worry. Don't see. If you want in a real time, everything, now our agenda will go away. Okay, let's not get into that.
No, no. I just want to know it's possible. Yes or no? Yes
It
or
is
no.
absolutely possible. In software, there is nothing is impossible. Hari.
No, no. I understand. Yeah.
No,
Sorry. Sorry.
absolutely. Only thing is, now I can't show. Again, I have to. I don't have a data
Understand.
set. I don't have, our.
No,
It's
no.
a.
Understand. Understand.
It's like showing everything in 1 or 2 hours is not the thing. You go to work.
No, no.
Yeah.
No,
So
no.
that's a good question. Just to keep it aside. It's a very simple. It's an additional parameter. Instead of all products, get only related products. That's and recommend those things.
Okay. Understood. Understood. Clear. Clear.
Okay.
Clear. Clear.
Okay. Let's move forward, guys, because we haven't even finished our base core things. Okay, that's a good question. Okay. So where I am. So this model, what I'm trying to say is, Nagesh, this model has this intelligence. So this is what now you can even save this model and can you can even retrieve, and always it is there. That intelligence is there in the model. I'll even show you. Now come here.
Okay.
Now what I'm going to I will take a break in a couple of minutes. But wait. What we're going to do is we're going to evaluate the model and test. So we have a test data. So for the test data, for test data, you all know the ratings are already known for the products.
Correct.
For that user ID and product. I will do a predictions using this model. I'll compare the actuals with predictions. Let me take this step here, just one. Here I will give you additional understanding about case also. Now, we already talked about case statement. You see here. See what I'm going is, I'm taking the test RDD. This test product RDD already it contains rating objects. Here, test rating RDD, Leela, test ratings RDD, where is it? Training, test ratings RDD, Harish, RDD is nothing but an RDD of, again, rating objects. That test rating objects, I'm going to use the test data now. My training is done. This test RDD, sorry, this is the test ratings RDD. This testing rating RDD, I'm mapping. I'm taking a rating object. Okay. What I'm doing it, I'm using case. Since I use case, I can tear it up. See, I just take user and product. See here, I have user product rating. From the rating object, I can create a tuple, a simple user and product. User and product. Way I'm doing is, I right now, because for this user product, I want to find the rating using the model. See here, Harish, using the model, I want to predict. I know I have rating. That I will compare it to what I predict. Using this model, for this user and product, just like here you see here, user product, this is the rating. User product, this is the predicted rating. User product, this is the predicted rating.
Are we predicting the rating or products?
I am predicting the rating for the user product of the test rating object.
Then it is not recommendation, right?
It is not a recommendation. I am evaluating the model. It is not the recommendation. I want to see how close they are.
Okay.
Let me, everyone, what I'm going to do is, now I want to just to check. I have ratings for my test data. I have ratings for my user products. I have ratings, which is my test data. That is the actual ratings. So for that user product, I will use model and I will predict the ratings. Then I will compare my actual rating with the predicted ratings and see how much is the error. How much is the error? That is for my, just to evaluate my model, to give some scoring. Hey, this is my error. This is my mean error. So to come up that, I am using it. That is not a recommendation. You are right, Emma. The recommendation is this. The recommendation is this. For a user, this is the recommendation. But this is for comparing. I know ratings of a user product, but I'll use the model and I will just pass only, earlier I passed user ID, user and product this time. User and product, I will predict, which is a recommendation based on the model. But I want to compare that recommendation rating, for that user ID product. This is the actual, but using the model, I predict and then compare. What is the ratio? What is the difference? Suppose the actual is 4. My prediction can be 5. Then what is the error? It's a 1. Difference is 5 is the prediction, 4 is the actual. 5 minus 4 is 1. So like that, for the test data, for each user, each product, I will get the rating. Then I will compare one-on-one and see, find out the average error. That is the idea we will do after the break. But first, at this moment, I want you to this case class. This case, not case class, case statement. Case rating. Harish, do you see this? Case rating. Since I need to pass only user and product to my model, how I can user and product? See here, see how beautiful it is helping you. Please see. This is, I'm running. See here. See, test rating is a rating object. RDDF ratings. I'm taking the rating. From the rating, how I am get a tuple, simple tuple. Tell me. See here, simple case of the rating object. I can just tear it out, user and product, where then I get all the users, all the user ID and product of the test data. If you want, I'll show you. I'll print it. See here, test product, take, right, for each println. Harish, do you see Harish? Okay?
Yes, Srini.
So this is a testing RDD. From the testing RDD, I used a transformation. How I did it, you see? Very helpful. I can tear it up and take this. Now I got a product ID, user ID and product, user ID and product, user ID and product. Now for this user ID, for this product, if I apply my model, what is the predicted rating I'm getting? I know I have already rating. That is the actual rating. This is the predicted rating. So what is the difference? That will help us to evaluate this model, to find out the score, RMSA, root mean square error. Okay, Emma, does that give you idea what we are going to do after the break?
A little bit confusing, Srini, because rating and predicted rating, I'm still not able to fully, sorry, maybe my.
I think you are thinking a lot, actually. I will show you side by side. If you see that, you will appreciate it. See, this is, see, simply go, if you simply think, see, what is the test I did? Let me go here. Let me give you one. But that's a good question, though. I appreciate that. But without think too much, you just say, do this. Take 5 for each println. Okay. Now, what is this?
That's a test data.
The test data. Now tell me, 253, 465, this is user ID, this is product ID. It has rating, yes or no?
Yeah, it does.
Yeah.
Okay, now you see. What is this? This is user ID. This is product. Okay. Now I will pass this to model and get the rating. This is actual. This is actual. Let me predict it. Now itself, let me do it. See here. So this is the tuple, right, Harish?
Yeah.
So test user product ID, I'm passing it here to the model. The prediction will give you what it will give. Let's see. Then I will also print predictions for test RDD. Take 5 for each println.
Each typo. For each.
No, each.
Yeah.
Okay. They may not came as in the same order. Now you see, Hari, see, this is the product.
Yes.
This is the user ID. This is the product rating.
Correct.
Then I got the user ID and product. Then I pass that to the model. Then I get user ID and product and predicted rating.
Okay.
Then I will, of course, here exact order didn't come. Then I will exactly take user ID, product, and actual and predicted.
Yeah.
I will compare these two. Okay.
Clear.
Okay. Anyway, yeah. I'll come back. We'll take a break and come back and see it. Hema, did you understand what is the aim? What we're trying to aim? I think you're on mute.
Yeah.
Okay.
Yeah, I think we are seeing how close the model we have defined is to the reality. I think.
Exactly. We are coming with some score. Hey, what is the difference? Now this is 5 and suppose this is 4. This is 1.
Yeah.
Then for every product, every user ID product combination, we want to find out the difference, then average it. Then that becomes a system score. Okay, we'll talk about it. Now it is 10:07. I want you to take 13 minutes break. So it is, we'll come at 10:20.
10:20, yeah.
13 minutes break. Okay, guys. Okay, welcome back. Let me quickly check if friends are here. Emma, can you hear me?
Yeah, friend.
Yes.
Okay, wonderful. Okay, let's make it simple, guys. Hari, now
Yeah.
how we can say our model is, how we can quantify our model? So now we train the model. Now we have test data. Now our test data is a ratings RDD. This test data, let me comment everything. This is test ratings. If I run, this is the test data. Right, Hari? And
Yeah.
I just, from that test data, I just took user ID and product. How I got it? Please see, this is a good way of writing code. Okay, case will help you. It can tear out this. Hey, you want user and product, you can quickly bring it. But okay, now you see here, hey, for this user ID, product ID, this is the actual rating in the file. It is in the file. This is the test data. Using training data, I have a model. Okay, let me apply that. Let me apply a predicted rating. Say, well, or let me say, hey, like this. Let me take the model. In that model, let me predict the rating 253 for this product, 253, and 465 is the product. Let me see whether I need to give it as a tuple or directly if I can give. Let me. It's a. Let me run this. Okay. You see this? If you see this, see, these are the ratings. And this is the product and user ID and product. For that user ID and product, this is the output. This is the rating I got, 3.7. If I apply the model, there is the real is 5. Ari, do you see that? Our model is predicting for this user ID, product ID, this one, but actually is this. So do you see there is a difference between these two?
Yes.
So like that, for every user ID product of the test ID, test data, we can compare the actuals with the predictions. Find the difference, just like this one, difference. The difference can be sometimes plus or minus. Sometimes plus and minus may cancel each other. If you average them, it may become even 0. That's why they take the square of it so that the negatives won't be there, the difference, and square it. it's always positive number. Then find its mean. So it's a root mean square error. So even use the common sense. How can we say what is the criteria or whatever that you get from your mind? Hari, please tell me, it's a question to you. We need to use some criteria to tell, hey, this much, we need to quantify this much, our model is this much good using test data. Tell me what is the common sense approach? Without this, use your own idea, you know.
Yeah, we can say that our model is like, 60%.
But how you say? Now you see, yeah, tell me.
Yeah, because we can say that based on the numbers that we see, because you say that here it is like, that from a model, it's like, saying 5, but actually it's like 4. So it's like comparatively, say, based on that. So it will be like compared to the numbers. So it's like based on that, compared to the model and your
Absolutely. It's a
prediction.
very common sense. You know, you've seen the Dawn movie, right? Movie Dawn.
Yeah.
That guy loses his brain. When he come back, they asked to recognize the people, right, Hari?
Right.
Amitabh Bachchan or Shah Rukh Khan. Once he start, hey, who is this guy? That this is okay, Harish Bokre. Okay. Oh, then okay, good. Then what he says? So Harish is actual. Then there is another. He is unable to recognize. So based on that, you score it, right? Okay, this guy Don. I think this guy is a real guy. You'll tell, right?
Right.
So you're right. Yeah, we have actuals. Now using the model, which is this actuals is from file. This actuals is from file. The data, the known for this user ID, for this product, this rating is available. For this product, for this user ID, using the model, what is the predicted value? Because as I told you, our model only minimizes the error. It need not accurately predict, even for the existing product. This is 5. Of course, this is test data. Even you can take the train data, even training data also, even though we have used the training data, when you do the matrix multiplication, even for this product need not be 100% equal. There could be an error. This is 5, but when you multiply the product, it may be 4.5. So it's an approximation because you are dividing this into this. Your mathematics divide this into this. Okay, suppose this is perfect, but then there may be more error here. Then you fix this error, then may be more error here. It's like you try to fix this may have error. You try to fix this may have error. So the idea is not making one rating perfect. The idea is making the whole system optimized. That's why they use the word optimize. So optimization. The word optimizing is very, very important, even for our regular life. See, some people focus on career. Some people focus on sports. Some people focus on hobbies. Some people focus on money. You may have a lot of money, but you may not have friends. Some people have more friends, but their career is not good. So it means they are maximizing in one area. But what management guru says is you optimize it. You optimize your career, you optimize your friends, optimize your family, optimize your investments, optimize. So overall, you should optimize the whole. So your system should be optimized. Okay. So even though this is five, using this model for this user ID, for this product, the prediction may be 4.5. 4.5. But it's okay. 0.5, there is an error of 0.5 in this case. In this case, there is an error of 0.2. But it is better, but it found the unknown value, right? That approximation found this unknown value. Here, we don't know what is its value at all. But it gave us this value. So that is how you need to see this problem. So I encourage you, don't get confused and don't make it complicated. Simply think in a simple approach. We have a model that can predict. We have a training, that model came from training data. The test data has user ID, product, and rating. Now, how can I quantify my model is good, or how much good, or how much error my model has, or how efficient my recommendation engine is with the given data? Going forward, it may become more efficient because it learns from the new data. But at this time, what is its score? How can I quantify it? Something like that. It is like your credit score. Hema's credit score, Harun's credit score, Kiran's credit score. How can you say it's a 620 for 650? Sometimes it is 640. Then they say it is improved, 649. So you cannot dispute it. They quantify it some. Okay, you can dispute a fact that affects your credit score. There's something like you paid your credit card, but somebody say you paid late. You can dispute the fact, but you cannot dispute the score. Okay, you cleaned up all your credit, all the disputes. Then they gave a credit score of 650. You cannot say, no, you have to give me 800. You cannot dispute the credit score. You can only dispute the one aspect of your credit report which might affect. Kiran, do you agree with me? Do you agree with me on that aspect? Does it give you some perspective?
Yes, Srini. Yeah.
So your scoring is some understanding. See, even when somebody approve your loan, okay, we want some 600 plus. They don't care whether it is 650 or 640, 625, etc. So you need to understand these systems are statistical systems. These are not, oh, you should have 649. These are not like our IIT ranks and engineering ranks. Oh, one mark can change things. No, it's a overall aspect. That's good. Having that understanding, Hema, what we're trying to do is very simple. We want to find some criteria to evaluate our model. We have test data. The only thing that user and product, they're always there. The only thing is any recommendation or anything is a rating. Some products don't have ratings, some products have ratings. But here, all our test data, whatever the test data is available, the input is a rating object. That is what it is. It's a rating object. Whatever those rating objects we have for that user ID, for that product as a rating, it is there in the file. It is there in our memory of our program. So I pulled it out, user ID products using case statement. So I have a Just user product RDD. Just user product RDD. For that user product RDD, I will apply my model and predict. I'll get my predictions. It means user product actual, user product prediction. Then for that combination of user product, I'll compare those ratings and I will subtract it and square it so that I have a square of the error. There is no negatives. And I'll find its mean. If needed, I'll even square root it so that since you squared it, they still a little bit normalize it. That is okay. Called RMSC, root mean square error. So that way, since we find its mean average, it's okay, this is the average. Like that you'll know, hey, this is the RMSC of my system, which is based on the test data and also some hyperparameters. So now where I have control to change my system. My test data, my train data is fixed right now. I don't have any train data. I can't get any more. Maybe next 1 month I get the train data. In next 1 year I get more train data. But as of now, this is what I have. Everyone says, right? Hey, I'm doing my best. This is what I can do. This is what I can do. Something like that. This is the data I have. Okay. Apart from this data, this model efficiency is also depend upon the rank of the matrix, K. The iterations are not big deal. Actually, our iteration doesn't affect the model. Rather, more for computation. Some extent it is because how many trials you do, it does the efficiency. But after 10, 20, it won't improve anymore because it quickly try to minimize very quickly. First you fix this, next the alternative least squares, right? Alternatively, it does 10, 15, 20. That is, you can put it. But main thing is K. K is that. Yeah.
Sorry, sir. Small question. The data that we are collecting, it will, for example, the times are changing. So over a period of time, how do we accommodate the change? Today we are
question.
Today.
See, that is a data engineering question. That is not a really big deal. There are a lot of people who can help you to get the data.
No, sorry, not that. That the data that we're collecting now, after 3 months, I want to change the input. So how do you do that?
That is what Hari. Right now you don't know, but that is very easy task in big data engineering. Don't worry, that is not a machine learning issue. Okay. Just try to focus on the class because I appreciate that question, but it is not really difficult. There are hundreds of engineers who can easily do it. Nagesh, you want to do any comment? You want? Harish says, "Hey, how can I get new data?"
Oh. How to get a new data?
Yeah.
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 So new data is like the my test data itself will differ.
Yeah. The question is same, Hari. Let's not repeat the question in multiple ways. Simply how to get new data. That's it. That's it. Now, after that, you split it to train, test. It's all okay.
Yeah.
The way I'm encouraging you aggressively is time flies very quickly in our class. You see here, it's almost 1 hour,
Sorry to
No, sorry. I'm just trying to encourage you how to do efficiently. For you, it is difficult because you haven't worked. But again, it's a team. It is a team sport. You may not get that. Somebody will give you the data. But those are the easiest thing in software. Always remember, those are simply, even you can automate those things actually. Why a lot of software people are even losing jobs? Because a lot of things can be automated. It's very, very easy. Software is so mature. You go and see, you'll be really, really surprised actually. The amount of maturity software tools have because of this open source, etc. Lot of things can be done very, very easily. But main thing is now more valuable thing is creating these models, testing them, improving the efficiency, solving the problem, etc. But anyway,
very true.
Just to encourage you, I want Nagesh answer, because Nagesh job is that only last 1.5 years. Hey, Nagesh, can you comment?
Yeah. I mean, the question is, how do you get data, new data, right?
Yeah.
Either this is like a different, if you have the source like a relational database, what do you do is right now you took it from one source, right? Either database or Hadoop file or any other Kafka or any other place. If source is that, and if you keep getting new data, today you got so much, you have a history, and tomorrow you get the data that you keep capturing it in Hadoop or database or anywhere. What do? You requery again, and whatever the query, whatever the data you want, you can push it to the place wherever you are, like running the machine training.
Exactly. So now my question is here. Thanks for the clarification. See, the model, we are talking about a model.
Right.
So that model will change, yes or no? So today you have a model. Tomorrow, based on the model, that model will change, yes or no?
Model change because of your data changing, right? Model won't change.
Correct. Model change based on data. Yeah.
Okay.
You're breaking, Hari.
Yeah, sorry. So is that something that we can, manipulate in the
Hari, can you adjust your phone? Can you adjust your phone and can you speak loud?
No, can we adjust our test data according to the changing time, or the model is a static thing, or that's what I want to know.
No, don't get confused, Hari. Hari, very, very simple. Your model is not static. Your model changes because of your data changes. Now forget about model. Now talk about data. How you get a new data? There are software engineering techniques to get you new data. We already have talked about unified big data lambda architecture, which talks about batch way of getting it, and what you call streaming way of getting data.
That's okay.
Srini, I think Harish is asking, he's missing one point is every time you get new data, you have to retrain that, right? So that means the model with the knowledge, let's not call it with just model. Model, you're talking about the object here. So when you retrain, the knowledge it infers from this data along with the model we are calling as an object, right? So that will change if data is changed.
Exactly.
See, again, I want
every time you need to do that, you have to get it that.
Nagesh, but there is no point. Just because data is changing, model don't change. It is your decision, your company decision. Okay, last 3 months data change. Now let us deploy our new models. So that decision makes the model change.
Right.
Yeah, you decide it's okay. Hey, we have already a million rows. Now this model, let's continue to another month. Last 1 week, we got additional 10,000 more. Just because data came, model won't change. Your data came through your Kafka to your Hadoop. it is available on this one, etc. You haven't considered. You haven't considered it to build a new model, right? You haven't decided. Your company says, okay, you're training it, you're training it, testing it, but you haven't deployed, right?
For
Right.
a very simple example, I will tell you, Srini. GST was not there in India.
Hari, let's wait. Okay, let's keep it offline.
Yeah.
Otherwise, we lose the time. Finally, we don't
Yeah.
get anything. Bottom line, it is one line. See, everything is a handshake. We need now. We need we will get the data. Yes, you will get it. You can train it. You can train it. Want to change it? You can change it. But those are all small things. Trust me, trust me, trust me. After that, you will appreciate it. Now let us do this. Let us finish this. Let us get how you get the RMSE. Let us calculate. Let us change the key. Let us do that. After that, you all getting new data, getting new training models, all those things. After that, later, everything is possible. You getting a new toothpaste. Colgate will give you new toothpaste. If Colgate doesn't give, Ramdev Baba will give you some paste.
No, I'm not talking about Ramdev. Sorry.
No. Let me say. I need to make sure everyone is in the same page. I need to progress the class. Otherwise, it's going to be difficult for you.
No, it's okay.
Yeah, Hari, we will take it up. No, don't worry. Okay.
Yeah.
But let's move. We need to focus here. So where we are, Hema, what we're trying to do. Let's not get to this one. We need to complete this. We need to test this model and improve this. Okay. We're not even talking about how we change the models. We're not even talking. We are not going there. First, we are talking about how you find some scoring for this. What you call this model? Where is our model? Let me go evaluating. Okay. Okay. So this is what exactly. So I have actuals. I have this model. I take the user and product. This user and test user and product, I will pass it to the model and use the predict functionality. I'll pass it and get the prediction object. Then I will compare it. That is what the whole idea. So let me comment this. This one I need. Harish, do you get this? This one I comment it. I just need this. I need to get this one. So this is the user product. I pass that user product, which is a test user product here, and I'll pass it predict based on the model. I'll get this predictions. So let me run this. Okay. So this is a user ID product, whereas this is again a rating object. Please see. Let me print this. Predictions test RDD. So let me finish this. Predictions test RDD. The output will be again a rating object. Harish, please look here. This is rating object. This is very important. This is the rating object. But this rating, Harish, is this a actual data in the test or predicted value?
It's a predicted value.
Predicted value. Now, what we are going to do is we are going to find its difference. Let's see how we are going to do it. Look here. Okay. See here. Predictions keyed by user product RDD. So what I'm going to do is I'm taking that predictions, rating objects, Harish. I will make them like this, user product and rating. That way I can compare it exactly. When I compare, I should compare user product and its rating, right? I cannot compare this product's rating to some other user, some other product rating. Yes or no? Harish. When I compare, I should compare this user, this product, exact user, exact product's rating to that user, that product's predicted rating. Yes or no?
Yeah, the grouping has to be done, Srini. Yeah.
Exactly. So, I need to prepare my test data for comparison. This is predicted data for comparison. When I'm comparing it, I need to take as a key value. That's why I'm grouping this. For this combination, this is the rating. For this combination, this is actual rating. This is predicted rating. How I do that? So this is my predictions rating RDD, which we got here. You please see here. Which one? See here. Predictions for test RDD. Sorry, jump. This is my predictions. From these predictions, again I use the case rating object. I get the user, product, and rating. This is my prediction combination. For the test data, this is my test RD, test rating. Test rating also I use the case, and I prepare it like this combination, user, product, this. Okay, Harish?
Yeah, Shani.
Okay. Now I have, this is actuals, this is predictions. Then what I do is, I need to compare these two, right? I need to compare these two. That's why I use a concept called just join. There is a join. If you join these two, just like a two table joins, if you table join them, these keys will match. This combination of the keys will match. This is the key and this is the value. This is the key and this is the value. When I say join of this to this, so look here. This one or this one. You start with the testing. This one you're joining to this. Join to predicted keys. When you join, these keys will be joining. These keys will join, and this rating side will come side by side. Let me show you how it is. Look.
It's like a self-join, right?
Transformation operation, right?
Yes, simple join operation. When I join it, I take this and print it here. I'm taking this and take it. I can use a known print statement. Let me comment this. I don't want to. It's a known. Leela, Hari, this is the predictions which I changed to the shape of user, product, and rating. This is the key. This is the actual. This is the prediction. These two I will join. When I join, these keys will join. So this is what happening. This test is joining here. Test is joining to the predictions. I get the output. That output, test and predictions joined RDD. I'm printing it here. Let me do it. Okay. Please observe. Test one is like this: integer, user ID, product ID. It's the actual rating. This is for predictions: user ID, product ID, predictions. So you join. When you join, the keys will be joined. Please see, Hari from India, Harish from USA.
Yeah. Okay.
These are the keys. Whereas this will come, since you join, they automatically will be joined. This is here, this is here. So this is actual, this is predicted. So let me, when you print it, you'll get this slide. So see here, 865 for this product. This is actual, this is predicted. 864 for this product. This is actual, this is predicted. 514. So because exact keys, these ratings should not jumble. For this key combination only, you need to compare apples and apples only. Right, Hema? Hema, you're on mute.
Yes,
So
Srini.
then I will find the difference of this. Each difference.
Are we going to improve this by improving the hyperparameters?
That is next step. First, I am finding the score. The score I am finding is each difference I will do it. Then I will find its mean, okay? Then I will come with one number like your credit score.
Okay.
So for that, I'll take this RDD, which is this RDD, right? This joined RDD, right? I'll take this RDD. Look here. I take this RDD. Then again, you see I'm using a case. This time, this user, product, this is test rating, which is actual. This is predicted rating. Is that correct, Harish? Emma? Is that correct?
Yeah.
This is now how I get the difference of this. See here. The error is, value error is this minus this, this minus this. So error square is this. Why you make square is because sometimes this may be negative, positive. If you square it, it becomes positive. So that's why when you add also, they won't sum up. Sometimes plus and minus may become 0. So this error, you square it and square root it. Square it and square root. So this is the error. When you square it, you get all the positives. You square root it. So after you get it, you get for every value. So every value. This one, every value. Right, Hema? The map functionality does for every value.
Yeah.
Then you this is the ultimately it is closing your square your curly bracket. Then mean means you find its average. Ultimately, this will give you score of that model, the system, that model, based on the test data. You applied this on the test data. So I'm running this. So I get the output 0.94. Average, the root mean square error, the error in your system is, error in your system means your predictions compared to actuals. If the movie rating is 4, you may predict it as some 3.1 or 5.9. So that is how it is as of now. So this is the score. This is the score, which is not bad, because for a lot of users, you don't know. You don't know the rating at all. Instead of 5, you predict it as a 4.1, but that's okay, because still many times it's a statistical. You will say, what are the top 5 recommendations? You will say the top 5 can be 4321 or 5432. That is not a big deal. But again, it's a fact. It is what you are doing your best. This is the data you have, training data. You trained it, you got the model, and you are applying that model on the test data. This is the root mean square error. Now, this is what you did best. But still there is a hope. Right? There is a hyperparameter where you have control, where you want to change and check for different hyperparameters for the same data, what will be different RMSC. Then based on that, you will choose the K. Any questions before I run it for multiple case? Yeah, Hema, does it make sense? Leela, Hari, does it make sense?
Yes,
Yes,
yes.
Srini.
Yes, Srini. Yes, Srini.
Yeah. Again, I'm saying, there is no perfect world. There's no perfect world. Okay. We elected leaders, thinking that they will bring changes. But again, things won't change overnight, or it may not meet all your expectations. Then we may elect a different leader. That's a different issue. But overall, are we trying to do some statistical aspect? We need some learning. That's why they find it as beautiful. It's a machine learning. So learning is all about ongoing thing. Not a perfect, my system is not perfect. We don't need to worry and cry. Instead, hey, how can we improve it? That is the whole idea. These are not OLTP, OLTP system, online transaction processing systems. When a user buying a product, the credit card is a $10 means you should absolutely charge only $10. That is 100% OLTP systems. After you correct it, you're trying to get insight of it. It's just like, hey, what is the average prices in Coimbatore? Hari, you live in Coimbatore, right? What is the approximate house apartment prices there for a 3-bedroom in a decent locality?
3-bedroom will cost around 1 crore.
1 crore, right?
Yeah.
So that is how regular life. You're right, Hari. That is how regular business is done. It may be 90 lakhs. It may be 1.1 lakh, 1.2 lakh. 1.5 also will be there. But generally, it's around 1 crore. Like that. That is how the businesses are run. So you said 1 crore. I came there. It is 1.1 crore. If I start fighting with you, Hari, what you will say? Oh man, these people from US, they don't have common sense, you will say, right?
No, I'll say it's an average that.
Exactly.
Right.
But you will say, but generally also, right? It is not, that is how the business is run, right? Okay. So since you said 1 crore, I cannot say why you said 1 crore, it is 1.1 crore. I cannot argue with you, right?
No, see, there are so many factors. No, it depends on how the apartment is.
No, that I agree, but let me tell you, in a common sense discussion, can I argue with you? No, right?
No, yeah.
That's what I'm asking. I agree with you, all the history and everything. Yeah, that I'm trying to encourage you to understand these systems like that. When you're designing these systems, you need to have a different mindset. You need to have a statistical mindset. That's why even some people say, this is a statistical machine learning. They use that word. So when you are going to build a career in this, you need to have a different mindset. Your mindset is you're building a system to improve based on statistics, based on approximations, based on something is better than nothing systems you are building. Okay, excellent, guys. Okay.
Yeah.
Now,
yeah.
Excellent. Very good. So, Hema. I said, Hema. So I will now parameterize the K. Now we want to change the K. I want to parameterize the K. Finally, I need to build a system and should know my RMSC. My RMSC, how I calculate it. I need to train the model. Based on that K, I am passing a K. I'm building a function here, Emma. I will give a k to this function. I should get my RMSC. How I am going to find out? So still again, I need to start everything, right? I need to build a ALS for that k. Earlier I hard coded. That is correct. I need to build a model. This time I need to again run the training on the training data, which is fixed. Training set is fixed. Since this is k is different, I'm muting everyone. Okay. So I'll be building the model. It's like a refresh. Now, again, now I got the model. How I get my RMSC? I need to do a predictions. The model is built on the training. I can use the test data. First, I can use the test data. Some people think, hey, let me find the score using the whole data. That also you can do. But let us understand the difference. First, go with the test data, with multiple case. Okay, I have model. I'm getting user products. Harish, why I need user products? Because I need to, for predictions, I need user products. So that's where, let me take the my test data. This is the whole ratings. Let me take my test ratings. And let me comment this. Give me 1 second. Test. Okay, so give me 1 second. Everything I'm doing again. Like I had to do it, right, Hema? Hema, you're on mute. I'm checking with you. Since I changed my K, I'm putting everything into a function so that I can run for multiple case. I can run this function just like we ran in the prediction time, right? Agree?
Yeah, to find out the optimum.
So that our friends understand what I'm doing here.
Yeah,
I am taking the test rating, right?
With a different number of case, so that we can find out the optimum value for the hyperparameter k.
Correct, very good. So then what I'm doing here? I'm training the model, right?
We are creating the model with the training data.
Correct. Now again, I need to apply on test, right? So these are test ratings. Okay. I have user product.
User and product for the test data.
I call it as user products. Then I'll apply that model, right?
And with the rating.
User product.
Yeah.
User product. I know I get this rating. I'm chaining it now in one statement.
Okay.
I get it. I get that RDD. Then from that, I use a product.
We are mapping the tuple to the rating, predicted rating.
Correct. So I have this now predictions in the form of this key and value, right? These are predictions.
And we have actual data, which we are forming in the tuple and rating format.
Right. Let me. Right. This is actual data.
And joining the predictions with that actual data.
Actual data also, I need to convert it to this format, right?
Yeah. We are forming it into a tuple of user product and its corresponding rating.
Very good. This is the
And
action.
then
Joining
with
it to the predictions, right?
So that for each key value, for each key, we will have two values. One is a prediction and other one is an actual value.
Excellent. So your rates and predictions will have a key and two values, ratings, actuals and predictions, right?
Yeah.
The error is going to be this minus this.
And we are finding
square it.
Average error.
Where is it? And finally mean it. And since you stored this into a value, I'm just using the word return. Return means it's like a output, giving output. If you don't give this,
User defined function.
it is automatically returns actually. Everyone. Please note in a function, when you are writing a map, you put this curly bracket, you give this bracket, then you can even give a multiple statements. That is the beauty of Scala. Harish, please note this. Once you say case of this, mapping to anything, but ultimately you map it to the output. These are only intermediate steps. Like if you are doing mathematics, let x is equal to 2, let y is equal to 3, then x into y is equal to 4, like that. The output is the last step, right? Harish?
Yeah.
Your teacher may ask, hey, how you got it without steps? Okay, I know I'm very smart. No, you copied from your friend, they will say. That's why show the steps, they will say, right? Like that, these are the steps only, but ultimately, this is exactly. So exactly whatever we have done, this whole thing, Leela, we are doing in a one function. Why I'm doing this? Because I have a k as the parameter. Earlier I hard coded. Now I have this function, I can pass the multiple case. How I can pass? So let us start some 40 is the k, or 20 is the k. 22, some 50. Change it by 5. Some people change it by 1. Not needed. Generally, 5 is okay because it's a k, right? K. These are not clusters. In clusters wise, 4 groups, 5 groups is okay. Here it's a rank, matrix rank. That should be okay. If you want to try, even you can try passing 1 also. You can do at home. Taking 20 to 50 means 20, 25, 30, 35, 40, like that. Those are the k. For that k, Hema, what I'm doing? Mapping for that k.
We are calling that user-defined function.
User-defined function, very good. Passing it. I'm putting it as a tuple so that I will have a output. My output look like k value, and it's error, right? Is that correct?
Yes. That function returns the average error for that
average
k value.
error. Exactly, and I'm printing it. So let me run this. Harish and Hari, are you with me? Kiran? Hope I'm not confused. What happened? End of the function. Something messed up.
Yeah.
This one is good. Something messed up.
I think end braces for the function.
Yeah? One more? No, I think somewhere it missed. Give me 1 second. So let me start. This is the function. It starts with this one. Hope it has end. These are simple statements. It's good. A user product is a map of case of this. This is also good. Right, Hema? Predictions is a model.
I think you have to remove the topic.
You are breaking, Hema. Can you adjust your phone?
At line number 17, at the end, do we need the curly braces again?
Join predictions. Okay, this is map of this. I think you're right. Yeah. Let me make it a little bit smaller. Hope you can see this. So your function is a k. It takes the input, output is double, an error. I'm going to run this. It runs 20. Don't worry about this. Just focus on this. Running. Leela, am I confusing you?
No, Srini, I'm following.
Okay. Narayana.
I'm good, Srini. I'm good.
Kiran, Kishore, Leela, Nagesh.
I'm good, Srini.
Okay, Sai. Okay, Sairam is good. Siva. Okay. Okay, very good. Yeah, it takes time because it has a number of iterations. Still, we did to 10. Right now, we are not changing it. At your workplace, you might change. You may even parameterize that. Mute everyone. Okay. Keep everyone on mute. But right now, don't worry about it. If you need, yeah. So this is how you got it. You have 20.90, 93, 94, 95, 95, 9512, 9581, 94. It's decreasing, but here it started. So then you might even start with 10, you know, like that, you know, you choose, you know, you can run at home. I'll share this code with you, run it for multiple values and see, then discuss with the team. But again, you are applying this on just test data. So some people, what they do is, Emma, they run the whole thing on the whole data. Even though they test it, they will see some scoring on this test data. But how about, you know, put a scoring on the whole data? Whole data. Whole data. Because whole data, when we have 1 million, sorry, 100K data, where is our 100K data? Let me, these are the ratings. How many we have? The total number of ratings, 15 total product rating, 100K. Total product rating. Let me do one thing here. See the beauty? Now Harun helped you guys last class, a data frame. Hema, what happened here? I have ratings RDD, which is a rating object.
And we converted it to data frame and printed it in the form of a table.
Yeah, can you tell to our team how it can be converted to data frame? Because your rating has a metadata, right?
Yeah. Ratings is a predefined object with user, product, and rating attributes.
Correct.
So
user product rating. Let me show you. So anyway, these minute things, slowly after you practice, you get it. Don't get overwhelmed, but see, appreciate the beauty, how you can play around with this. I'm using it as RDD. take 5. Harish, this is for you. Please see. Println. From RDD level you are playing. So that's why you are taking this, and for each you are doing a println. You found it's a rating object. This is, this is a user, this is the item, this is the rating. This is a class. Rating is a class. So your rating is a class, sorry, rating is an object here, though it came from a class blueprint. The class.
Sorry, this is the actual, right? This is actual.
Yeah, these are actuals. But now the point is not actual or this one. I'm just showing you your ratings. The whole ratings I'm showing. These are actuals, right? You're right. You're right, Hari. Let me take my word there. These are the original file actually. This is the rating. This is the rating object, rating RDDs. How you got the rating RDD, please see. See, this is the raw data. This is user data. And we took these 3, which is an RDD of string. Then we split it. Then we become RDD of array of string. That you passed it to that array into a rating object, which is the input for us. Which is the input. Input means it has both training data and testing data. It's a whole set. You're right, Hari. Is that correct?
Correct. Why I asked you that question is not anything, but just to go back to my earlier listing, that now you are saying this rating is actual, and we have to compare to our model where we are predicting. So there exactly. Exactly. So that's why I just wanted to clarify that.
No, absolutely, you're right. You're on the bullseye. So this is the ratings RDD. Just for information, since Harun is helping us on data frames, I'm just showing you the power of data frames. These ratings RDD, these are rating objects, but rating objects are created from rating classes. Those classes can be regular classes, or the classes could be case classes. So those can be converted to data frame and showing it as as a table. Harish, do you appreciate this?
Yes, Srini, yeah.
Okay, that's good. You see now, no, these are actuals, as Harish said. Now, okay, instead of test data, I'll take the whole ratings RDD and see. I'll try to apply into my function. Instead of test data, because still some we can score the system. Okay, so user product, instead of testing data, I will take my rating. So this is what I did here. I took from ratings RDD. Okay. Then my predictions based on these user products, the user products of all ratings actually. So I got my predictions. So then I will join. When I join it, okay, I'll use the original ratings, which is this ratings RDD. Ratings RDD. Leela, don't get confused. Ratings RDD. Instead of test ratings, I'm taking the whole ratings. Ratings RDD. I have this user product, and this is the actual rating. And I will join to the predictions, which I got from the whole data. So I got the predictions of all data, and I have actuals of all data. Emma, is that correct? Then I have this actuals and predictions. So that rating and predictions for all user IDs, I have actuals, I have predictions. This is the error, square of the error, mean of it. Just run it. We have this. Just run it. Okay, guys, so we will spend 5 more minutes. We spent a lot of time and very good time, very good discussions. I appreciate, especially if you can build we can solve 2 problems and learn Scala and learn this big data engineering, data frames, and how you write these functions. Then literally, you can start solving the problems. Then after that, it's just a matter of applying different algorithms for different problems. But at least you know how to solve 2 problems. So let's review this. Then I'll give you some assignments for this week. And tomorrow we'll meet at 8 o'clock. Harun will be engaging, taking additional insights into data frames and taking files from Hadoop, running on the cluster. All those things we can do. Okay, let it run. Let it run. So what we did to summarize? To summarize, we took the whole ratings data, split it, created ratings object. Ratings object is the crucial for us as input. That you pass it to model. Model has hyperparameters, especially the rank, k, number of iterations. That also you can focus when you want to tune it. But again, it's a 10% of work. Please note, the 90% of work is all this work. So you trained it, then applied on test, and you found some score. So this is the score of my system, and run on with multiple case. So that is where I'm just passing multiple case to a function. The whole thing, whatever I done, I captured in a function. See, though we discussed so many details, how beautiful it is now. In a single function, everything is captured. Now you please see. The 10, 15, get to 50, the 31, 32, 35, 41. Now you see, it is decreasing here. Now you might even increase this. So 50 to 60, or you may start with 50 to 60, 50 to 100. So like that, you would run multiple, then you bring out the data, discuss with your team. Hey, on our test data, we got this is the score, based on this is the K. If you use the whole data, this is the K. Like that, you do a lot of deliberations. The machine learning, a lot of practitioners tell, it is not just a pure theoretical aspect. A lot of artificial intelligence is built based on empirical data. A lot of trials and errors. The practices are developed based on what you called doing it, using the judgment. What could be this? What could be the threshold? Shall we increase the threshold? Shall we decrease the threshold? Everything is a lot of deliberations with the team, based on a lot of discussions using common sense and with a given knowledge. So that way, you be open, and with a flexible mind, you can able to work very efficiently on the machine learning projects. But the process, high-level process, remains the same. Working with big data engineers to get the data from multiple data stores, and doing a specialized cleaning that is needed for your machine learning project. Specialized cleaning means dropping some columns, converting them to the dense vectors in the case of k-means, making them into rating objects for this one, for recommendation models. So that approach will help you to build efficient systems. Okay, guys, any questions before I give you some assignments, some work for next week? Kiran, does this help you to gain some insight so that you can play around additional? Harish, Harun, Kishore, Leela?
Okay.
Yes.
Nagesh, how does it sound?
Good, say.
That's a good training.
Okay, I'll share it to you, this code, but I have something to share, some improved version. Improved version means before you even train the model, you want to do additional analysis, some insights. I know we have user ID, product ID, and rating. Hey, I want to know what is this product description, because when you work, you may want to know, is it iPhone or is it a book, something. Hari, is that correct? So you might have to join to the metadata. So that is where your data frames will help you. See here, I have a give me one sec. Okay, so I will give you this data also. U.user means user description. U.item means item description. See, the item can be like this. This is the item ID, which is product ID, movie ID. Description is Toy Story. When it was released, what was the IMDb URL, and some other genre information. In the case of users, give me one second, and I think I need to run. Yeah, in the case of users, it could be, let me see if I have. Yeah, it is a user ID. That user has certain age of the user. What is the gender, male or female? What is the occupation of the user? In which zip code they are there, etc. This is all metadata. The movie metadata, user metadata. Hema? But for our ALS, we use user movie rating. User ID, movie ID, rating. That is the only three needed for our model training. But for exploratory analysis, just to join them and see which movies has maximum ratings, different things, just like our table queries. You might have to join rating objects to movie metadata, user data. You want to know the description also. So in that case, you might have to create a data frames, which Harun is helping us. You can create a user data frame, movie data frame, and rating data frame. So for that, you'll be creating case classes. You're creating this time. Okay. So then you can, sorry, here itself I've given. You can even one stroke, you can take the user data and create a data frame. You see here, even parsing, you can use some functions. What I mean is, you do a line dot split, Hari, line dot split. You do all these splitting things. Even those splitting things, you can pass this as a function. See here, I can parse as a user. If I'm creating a function, this function is exactly doing nothing but, see, it is splitting it. Then after splitting it, it is passing that whatever the whatever you split is passing into user case class. See here, it is passing here. It is parsing movies. It is splitting the movie. There they have a what you call pipe as the delimiter. The data, I will give you the data. Pipe as the delimiter. But sometimes simply see, sometimes you can use double quote, sometimes use single quote, depending on the issue. I found in the case of pipe, I don't know why, double quote didn't work. In the case of comma, double quote did work. Maybe we can discuss later. Hema, explore that. Just a hint for you. So you can pass it as a function. So little bit efficient way of writing code I'm trying to give. So I'll share this to you also. So after you creating these data frames, I think Harun will explain to you how to create a table. You can create a tables of the ratings object, movies objects, and users objects. Then you can run some queries. You can run some queries to find out the maximum ratings, minimum ratings of the count. This is nothing to do with the training model. This is just I'm telling you, as is, you have a ratings data, you have movie data, you have users data. You want to know your data. You want to analyze your data just to get sense of the data. So this is where you just to do some exploratory analysis. Means you are doing a joining for these movies. This is the maximum rating. This is the minimum rating. Different users have given. Then this many people rated the Star Wars movie. All these things, some questions you can do it. But that is all just to get to know the data. Let me not confuse you. Okay? I'm just telling you additional tools for you. So I'll share this to you also so that you can explore. Then I will give you this data, which I already given the link. When you download, you get so much data files. So there is a README. There is a README file in that download. In that README, Harun, you asked me. See here, they will tell you. See, user data, a full U data with 100K ratings. User item, they will give you the what you call the schema. User, you see here, user ID, age, gender, occupation, zip code, different information they will give. So that is documented. Harun sometime back asked how we know which column is what. So that type of information will be documented, always there. So I will be sharing this improved version, which has what you call those data frames, which you can play around. But more than anything, I'll share it to you what is working in our class. Then I will again give you on the Facebook, I will post to you where you can find the data so that you can download. So any questions, last 2 minutes for tomorrow?
No, Srini.
Nothing much, Srini.
Okay, I know it's a heavy class, but good questions, guys. Hari, Narayana, Harish.
I'm good, Srini. I'm good.
Harish,
Thank you.
Thank you.
You think you're learning, Harish?
Yes, Srini.
Yeah.
Kiran, does it help you? I know still you need to drill, you need to go through, slowly run it. But does it helping you? Kiran? Okay. Nagesh, how does it sound? Siva?
I'm good, Srini.
Okay.
This is very good, actually. I mean, it's a dry subject, but you made it as interesting. Thank you.
Okay. Excellent, guys. Excellent. More than anything, always remember you are getting tools to solve problems, big problems for the companies. That will add a lot of value. Okay, great. Excellent. Then we will we'll end this meeting and we'll meet tomorrow. Okay.
Thank you, Srini.
Thank you.
Thank you all. Good night
Bye.
and good morning.
Thank you.
Thank you, Srini.